Hello and welcome to this talk about service broker integration with Kubernetes operators. A few words about myself. I'm Julian Fischer, CEO of a company called Anynines, and our mission is to create application developer platforms. So whether this is with Kubernetes or Cloud Foundry, whether it's about planning, design, or operating it, that's what we do. We want to think about how service brokers can integrate Kubernetes operators. So first of all, a little bit of context. We've been researching and developing and implementing automation for data services for more than 6 years now. And the major paradigm in data service automation these days is the on-demand provisioning of dedicated data services. The main point is that the on-demand provisioning of dedicated instances is the leading paradigm here. This is in contrast to, for example, shared databases where you have a Postgres server, for example, and carve it up into particular or into separate data service instances using databases. In the case of the on-demand provisioning, you'd be using dedicated pods or dedicated virtual machines to represent your service instances, or even clusters of VMs or pods. So you have a service broker, you trigger automation, you create a dedicated VM, dedicated pod, or a group of dedicated VMs, group of dedicated pods comprising a clustered instance in the second case. So the first idea you may have is there a way to have or implement a generic service broker that implements arbitrary operators or integrates arbitrary operators, to be more precise? And I personally think that this is possible, but it may be challenging. And we are going into the question, how generic can or should the service broker be? Before we do that, I'm not sure who of you have been familiar with the components such a service broker will have to orchestrate and trigger, and therefore we'll spend a few minutes on the building blocks and presenting them. So obviously, if you use Cloud Foundry, you're very likely to be familiar with the service marketplace, where you do CF marketplace and you get a list of all the services offered on your Cloud Foundry platform. Now, this marketplace basically is generated by the cloud controller of Cloud Foundry, where the service brokers are registered. And by retrieving information from the service brokers via the get catalog function, the cloud controller knows which service endpoints these service brokers offer and enable the Cloud Foundry marketplace listing. So the main point here is that each service broker needs to implement the Open Service Broker API. The main terminology introduced by the Service Broker API is a service plan, a service instance, and a service binding. The Open Service Broker API is fairly simple. It has some methods, REST endpoints, to retrieve the metadata as the service catalog, create service instance, and create delete bindings as well as delete them. So much about the service broker. So it's worth having a look into Kubernetes operators. The operator SDK has been around for a while. For those who are not familiar with it, it's basically a set of tools that makes it easier to create other constructs that are Kubernetes abilities to extend Kubernetes. And one of these constructs the operator SDK facilitates is custom resource definitions. Custom resource definitions is about describing a new data type and tell the Kubernetes cluster how to create an endpoint for this new resource and also store it in its etcd store. So if you look at this example where there's a description for a new Postgres type that has the attributes replicas and Postgres version, once you have this custom resource definition applied to your Kubernetes cluster, it will be able to store objects of this new data type called Postgres. Here the kind is Postgres SQL, and objects will look like that. Of course, they can be more complex, more attributes, but you get the idea. So custom resource definitions tell the Kubernetes API to store new data types, custom resources, and introduce endpoints so that you can use the kubectl command to create Postgres objects that have not been known to Kubernetes before. And along with offering endpoints, Kubernetes will also store the objects you create persistently in its etcd. But what it's not going to do is implement any behavior on what such a Postgres object is about. This is where controllers come into play, and you write them down in Go code when using the operator SDK. And these operators are basically about monitoring the primary as well as secondary resources. So in the example of our Postgres, the primary resource would be the Postgres object that a user may want to create. And you may want to translate it into a service and a stateful set, which would then be the secondary resources. In this example, the code example, there's a memcache object where the primary resource is memcache and the secondary resource is a single pod. Then these controllers, they do have a reconcile or a loop, a function that is called where you check the desired state versus the actual state. And what this function basically does is twofold. First of all, what the operator in this case does is twofold. First of all, it watches the primary object specification and translates it into secondary objects. In this example, it's looking up whether a memcached object exists, and if not, it creates the corresponding pod. In our Postgres example, this would be about creating a service and a stateful set, for example. So a controller is basically reading those custom resource object specifications and translate this primary resource description into a set of secondary resources by using other Kubernetes resources. Well, most of the time you'd be translating, let's say, the Postgres object into Kubernetes native resources such as services and stateful sets, but you could also have a hierarchy of custom resources along with their controllers until you eventually hit the Kubernetes native resources. Yes, it will also watch the primary resources for changes, and it ensures that the secondary resources comply to the specification as well. So, for example, if you delete a stateful set of a Postgres instance, the controller could recognize that and recreate it, such as the stateful set would recognize if you delete a pod and would recreate it. Yeah, few thoughts about designing the service broker. The service broker integration with operators, first thing you have to do is figure out how would you map a service broker method to the behavior in your operator. Now the first gotcha is here where like enumerating the catalog meta information isn't a problem, and creating service instance is what most operators support. Not every operator has a correspondent or a meaningful replacement for creating service bindings. In fact, many operators don't have anything to create a service binding. Once the service instance is created, they don't care how you create a database user. There are operators who have that functionality, and that's where an integration would be more easy, but still one big problem seems to be apparent when integrating operators is if there's no functionality, API or custom resource that represents a service binding, the integration will require additional effort. So now let's focus on the important use case of creating service instances for a second. And the basic idea is that a CF create service triggers a controller, triggers the service broker. In this service broker, what it does is it combines all custom parameters. For example, if you create a Postgres, you could add custom parameters about where to store logs or whether to use point-in-time recovery, wall shipping, or not. These parameters are enriched with parameters gathered from the specified service plan. So the service plan may, for example, contain the information whether 1 or 3 replicas should be used in the stateful set, and also information about their vertical scale, for example, memory and CPU shares. In a BOSH-based environment, you would also resolve cloud properties, which won't be necessary in a Kubernetes environment. But at some point, you will have to generate a specification that will then be handed over to the Kubernetes API, where the operators take those specifications and translate them into secondary resources. As I mentioned earlier, this could be a recursive chain of responsibility until you hit Kubernetes native resources, and Kubernetes will actually do the rest for you. So such a create statement may look like this. It will, on the service broker side, generate a request like this containing the information about the service plan, which can then be resolved into the service plan attributes, which then can be followed up until you have all the information about the vertical and the horizontal scale of the service instance, so that basically what you're doing is building the data structure containing all information necessary to create that service instance. So it's basically, in the end, what you do is transform the incoming data of the service broker into the object specification of your custom resource. For example, the Postgres object you've seen earlier. And then hand it over to the Kubernetes API, which will then trigger the reconcile loop within the controller, which will then translate it into secondary resources. So that on the right side would, for example, be such a more complicated real world, so to say, version of such an object where you specify a Kubernetes resource. A few words about service bindings. As I said, they are unknown to Kubernetes and unknown to many operators. So if you want to look into, or if you want to integrate an operator with Kubernetes, you may have to deal with that problem. So one architectural draft to deal with this could be, as we've did it in the anynines data service framework. Well, there's a construct called the SPI, which is a little bit comparable to a BOSH CPI. We call it the Service Provider Interface, SPI. And this is where the service bindings are being created for a particular data service. Now, in my opinion, the creation of service bindings shouldn't be in a service broker plugin, because if you want to make Kubernetes developers access your data service from Kubernetes and using the Kubernetes API alone, the service bindings should be represented by custom resources with an appropriate controller, which is where the logic should reside. So in this case, the SPI wouldn't create the database user for your Postgres, for example, but instead create a custom resource definition, triggering a controller to do that for you with using Kubernetes means, for example, like executing a job that would connect to the service instance and, do the heavy lifting of creating that user. If your operator doesn't support creating a service binding, well, then an SPI plugin would be necessary so that the service broker knows how to do it. So it may be interesting to restrict the application developer using the Kubernetes API to modify a service instance that's used by Cloud Foundry, that has been created by a Cloud Foundry application user, to make things easier. So in particular, the question is, should Cloud Foundry and Kubernetes users be able to modify a certain service instance? And I would say it is technically possible, but it requires a back and forth communication between both the Kubernetes controllers as well as or the Kubernetes API, as well as the service broker API, or even the cloud controller, to keep those two entities in sync, especially because the cloud controller tends to store information about service instances. If you would delete, for example, a service binding or a service instance that has been created and has still metadata in the cloud controller, this would lead to data inconsistencies. So to keep things simple, it will definitely help if you'd declare each service instance to be either in the responsibility of a Cloud Foundry or a Kubernetes application developer. So let's sum it up. A service broker integrating arbitrary operators may not be worth the effort. It is possible, but it may be too complicated to do so. Assumptions about the operation to be integrated are necessary, of the operator to be integrated, are necessary to be made to make the service broker economically viable. So in our case, for example, the assumption is the operator will have a custom resource for the service binding, which makes the creation of service bindings much easier and generic. If you don't want to do that, you will lose the generic part, because then you'll have to create a plugin for each data service describing how to create a service binding. So you can say the more homogeneous the functionality of your operators, the more generic and the easier a generic service broker can emerge. The operator must provide a specific functionality because, as I said, there's no service binding functionality. Well, then you have to take care of it yourself, and certain lifecycle operations, for example, creates and updates, well, obviously they have to exist as well. The service broker will be much simpler if you have that restriction where a Cloud Foundry user creates service instances used by Cloud Foundry, and Kubernetes users create instances used by Kubernetes users. Read-only access should be possible from both worlds, even if they are mixed, but creating and modifying, deleting and modifying, they should be exclusive to either Cloud Foundry or Kubernetes users. Well, thank you very much so far. I hope you have learned something in this very, very quick tour about how service brokers can be used to integrate Kubernetes operators. We'll have a 30-minute deep dive session in our YouTube channel at youtube.com/anynines. So if you want to go through that material in at a little slower pace, please feel free to visit that channel. So if you have questions, just feel free to ask, and already thank you very much. Hello everyone. Well, service brokers, there any questions? No questions have been asked so far. So feel free to ask whatever is concerning you after the talk. Thank you. Are there any questions concerning the service broker API, concerning Kubernetes operators or their integration? You mean Kubernetes itself or the Kubernetes implementation that we have done? The question was, how mature is the Kubernetes side? Well, the service catalog plugin, it assumes that there is a service broker that actually does the automation and implements all the implementation logic, which is basically the primary automation. And the service catalog then provides the option to create custom resource definitions, and it will create custom resource definitions for you so that you'll be able to consume a service broker within Kubernetes. So the service catalog is always useful if you have a Cloud Foundry data service implementation, such as the anynines data service that will come with the service broker, and then talk to Bosch to actually do the on-demand provisioning. And if you want to integrate that with Kubernetes, you'd be using the service catalog. And I think that's, or at least from our experience, it's okay to use. Now, the approach that I explained in the talk would be the other way around, that you create an Kubernetes operator where the actual automation takes place within Kubernetes and where you provide custom resource definitions and controllers. And controllers will then take care of the actual automation by scheduling the stateful set, which will then, use container images that do contain all your scripts. So the service broker in the example I've shown is basically a secondary or a means to an end. So it's just an adapter to integrate the Kubernetes API by using those custom resource definitions. So both is valid, and especially if you have operators already and you want to integrate them with the Cloud Foundry, then the way that I just earlier explained in the talk would be suitable. If you have a service broker that, for example, comes from the Cloud Foundry ecosystem, and it does the automation already, and you want to integrate that with Kubernetes, then you'd be using the service catalog plugin. Well, if you have native support with custom resource definitions, then you don't need the service catalog, because the service catalog actually does create those custom resource definitions for you. And it also introduces the concept of a service binding just to reflect the circumstance that the service broker to be integrated will have support for service bindings and service instances. Are there any other questions or comments? I think we have a few minutes left. All right, then. Thank you very much for your time. Pleasure talking to you guys. If you have questions that pop up into your mind later, feel free to reach out. It's at Julian Fischer or at anynines, and we can then use some Slack channel or have a Zoom one-to-one to go through your questions. So thank you very much, and see you in the next talk or at the next conference. Bye bye.